Good morning.
Okay. What did you say? The microphone's on from nothing. Right, so yesterday, remember, we were looking at rearranging these to be which format?
Y equals
mx plus c.
Okay, why is y equals mx plus c helpful for us?
yes.
Why? WHY is mx plus c.
Because it helps us plot coordinates.
Wait, no, find the gradient and the rise of a thingy.
Yeah.
Well, let me help you with a better question. What information does it tell us about the graphs? Sydney.
It tells us the y-intercept and the gradient of the line.
Awesome. Now, which part tells us the y-intercept?
C.
This part, yes. So this is the C. And which part tells us the gradient?
M.
Okay.
Good job.
We know that if they're in this format, that they are what kinds of graphs?
A straight line graph.
Okay, perfect. What does y-intercept mean?
Where it crosses over the y-axis.
And which one's the y-axis?
The vertical one.
Oh my gosh, you're all wonderful. Okay. So, in a number of cases, you'll be given certain information and asked to provide the equation of a straight line. Okay? Now, we have to give the full equation of it. Okay, so that means that they're going to give us some information. We need to then end up with something that looks like y equals mx plus c. Okay? So, the easiest thing to do is to remember that we just need to establish what the gradient is and what the y-intercept is. Okay? So, this first example here, we've been given the gradient and they've told us one coordinate or one point that sits on the line. If we know that a graph has a line has a gradient of 2, what does that mean that my equation is going to look like? Do we know any part of it? Y equals
2 over 1. Y equals 1 over 3
Oh,
plus...
we've got lots of people saying stuff at the same time. Shh. So Ava, tell me.
Y is equal to 2x plus c is 3.
Yes, awesome. So shush now. What have I learned? So we know that because they've told us this part here, our equation is y equals 2x plus c. So we don't know c yet, but we do know the 2 part. Okay? So that's a good starting point. But because they have given us a coordinate that sits on the line, it's given us some more information. And that's going to allow us to now establish the value of c. What does this 1 represent when we're talking about coordinates? X. And the 3 represents
Y.
So what we're going to do now is we're going to substitute those values in place of the correct letters. So we're going to put the 1 in place of the X, and we're going to put the 3 in place of the Y. So we've got 3 is equal to 2 lots of, it's a major pen change here, plus C. Now, I put it in brackets because we're substituting, remember. Okay, so it's going into the expression. So 3 is equal to, what's 2 lots of 1?
2.
So we've got 3 equals 2 plus C. How do we rearrange it to get C on its own?
Minus 2.
Minus 2 from both sides, so we've got 1 equals C. Now, where do we think that number 1 is going to go?
And C.
Up here, over here, yes? So that's going to go up there. Our final answer is then y is equal to 2x plus 1. That's it.
So what happened to the little square thing in the x to the power of 1 and y to the power of 1 and then x to the power of 2 and then y to the power of 2?
Alright, so that's those general coordinates, remember? So they represent just a general thing. And that's how we would find the gradient if we were given 2 points. And we're coming on to that in a second. Okay? So if a question has given you a coordinate or a point and a gradient, you're just going to establish what the gradient is, substitute that in, then substitute the coordinate in to find C, and away you go. Right, so here we go, we've got another one. New coordinate, new gradient. So, Zoe, how am I going to start this bad boy off?
Just you do y equals 5.
Trace, yeah?
Wait, could you go up a second? Why did the y? I thought the y was 3. Why did the y come back?
Okay, so this is our general equation. Okay, so it's always going to be y and x. So your equation of a line will always have a y and an x in it. Okay, so they gave us this specific point that goes through that. So we are able to change the x and the y to numbers.
Yeah.
Just when we are, oh no. If we want to change the y, then we would change the x as well.
Mm-hmm.
So we're only going to do that in order to find some additional information. I don't think I've said that very well. Beautiful face. The whole idea is we want to end up with the y and the x still. Okay? But in order to, we had too many unknowns. We've got a y that's unknown, we've got an x that's unknown, and we've got a c that's unknown. So we need to establish what this value is here in order to finish off the equation. And so that means that we're going to use some additional information. So they've told us that when x is 1, that y is 3. So that's what we substituted in here. But x is not always going to be 1, and y is not always going to be 3. So that means that we need to go back to just x and y. Does that make sense?
Yeah.
Alright, so whilst I'm doing that, I think some people were merrily going ahead with this bad boy. So what do we do once we've substituted in the gradient? Elsa?
Then you substitute in your, well, first your coordinate, and then you substitute the x and y
Okay,
values.
so tell me what's right.
So it would say -2 equals -4/5 times 4 plus x. C. Plus c, sorry.
Trisbia. Okay, so obviously we've got nasty odd fractions, but we've got our wonderful calculators to help us. So we've got -2 is equals -4/5 multiplied by 4.
-16/5.
Nice. Did we all remember that that secretly was over 1? Or did
Yeah.
we just use the calcs?
We use the calc. Over 1.
Yeah, but most of you just use the calcs.
Yeah.
Okay, and then how do we find C?
Plus.
Add 16/5 to both sides.
Take away, wouldn't you?
No, because it was
A negative.
It was a negative.
Oh.
Did you miss that bit?
Yeah.
Alright, so what's -2 plus 16/5?
2.
6
Oh, never mind, I got that.
6/5.
Equals C.
Okay, so C is equal to 6/5. Where does that go? At the end where the C was.
So it'd be y
So Y equals, yeah?
-4/5 x plus 6/5.
Tresbians.
Could you also just leave that as a decimal?
I would suggest no. It's not officially wrong, but it's not as mathematically common to leave it as a decimal. We are going to look at stuff like this a little bit later, in that sometimes they want to rewrite the format of it, so they don't want it left like this with lots of fractions going on. But we'll look at those in a little bit.
How did you get 6/5?
Okay, so this, you can chuck it in the calc, okay, but if for any reason your calculator's broken, we know that -2, so we've got -2 whole ones, and we're adding on 16/5. What's the rule when we add fractions? When we just add the numerators, what needs to happen?
You need a common
Same what? Same denominator. What's my denominator currently at the moment?
1.
Okay, so we need to make them both denominator of
5.
5. I suggest, yeah. So we need to multiply both top and bottom by 5.
Yep.
So we've got -10/5 plus 16 over 5.
Oh, and that's how you get
So you get negative 10 plus 16 is 6.
Yeah, so C is 6.
Tristan? What's going on over there?
I'm thirsty.
Pardon?
I'm thirsty.
Then you should bring your own water. Right, next one, B. So these examples, we're not told what the gradient is. Okay, they've just told us 2 coordinates or 2 points that sit on a line. But we've learned that we can find the gradient if we're given 2 coordinates, haven't we? Remember we did that a few lessons ago? How do we find the gradient if we've been given 2 coordinates?
Is it x to the power of 1 and 1?
Wait, not to the power is.
I mean,
subscript.
yeah, x1, y1.
So I'm going to call this x1, y1, good. And this is going to be called
x2, y.
x2, y2. And then how do we find the gradient?
It would be y1 minus y2
Okay, so that's 4 subtract 1,
over 8 minus 5.
8 subtract 5, good. Remember,
I thought it was
it's the rise.
I thought it was Y2.
Yeah.
And I refer back to the fact, does it matter which order, which one is 1 and 2? No, so yes, our formula, if you like, the thing that I wrote up said y2 minus y1, but remember I also said it didn't matter which one was x2, x1, x1, y1 and x2, y2, okay? So it doesn't matter as long as you are what? You have to make sure that you are, pardon? The y is on the top, and also you need to make sure you're consistent. So because we started with this coordinate on the top, we had to start with this coordinate on the bottom as well. Yes? You all remember that?
How do you know that? And for B, they're asking you to find the gradient.
Say again?
How do you know that for B, they're asking you to find the gradient?
Because in order to find the equation of a line, we need to know the gradient. And we
Yeah,
need
but
to
like
know the
for,
y-intercept.
so this is like, oh,
So this is the situation that I'm saying to you. In a question, you will either be given something that looks like this, and you're like, brilliant. They've already told me what the gradient is. I don't have to do as much work.
so for this one, you're trying to find, like, you're trying to get the gradient and the y.
Yes. So we have to do more work for these ones. So when you see these ones, you're like, oh, I've got to do that extra step. Hey, what are you doing down there?
Nothing.
Try and maintain a little bit.
Sorry.
Right, okay, so we've got 4 take away 1 is?
3.
And 8 take away 5 is?
3.
What's 3 and 3? 1. Oh, our math skills are outstanding today.
Good question.
Right, so we've got our gradient now, so we know that 1. Where does that 1 go? Oh, before x. So we're going to start off our equation as y equals what?
X.
Now, I'm gonna write it in here just for the crack, but in reality, Julia, you're correct, you could just write x. Okay, so I'm gonna keep my 1 here just for my working set. In our final answer, we wouldn't have 1. Remember, we don't write 1 in front of letters. So now what are we gonna do? We need to find c. Oh gosh, this is happening. What do we do? Substitute. So we're going to substitute in. Now, we actually have 2 different coordinates here. Do you think it matters which one we choose to substitute? No. Which one would you like to substitute? A. Oh, okay.
A. Plan A.
Okay,
A
I've got more A's. Would you like to do the B as well, just show it's the same?
No.
I'm doing A. I like
You believe me? Alright, let's just do A then. If you want to do B, you can, you will get the same answer. Okay, so I'm choosing this coordinate here. So I'm going to say that, oh, I should leave the colours still. 4 is equal to 1 log of 8. Oh, I just wrote that. Plus C. What's 1 times 8? 8. So we've got 4 is equal to 8 plus C. Subtract 8 from both sides, so we get negative 4 is equal to C. So where does that negative 4 go? Back up to here, yep.
Y equals
So our final answer is y is equal to x subtract. And that's especially going back to the fact that we don't write ones in front of the x. Wait! Hold your horses.
Wait, no, wait, I got it. I got a question, but I figured it out.
Amazing. Alright, next one. Same thing, 2 different coordinates. So, what's the first thing we have to do, Erin?
We have to label the x.
Sure, okay. x1, y1, x2, y2.
And then you have to do the y's on the top and the x's on the bottom.
Okay, and what are we doing when we're doing this? We're finding the
Gradient.
good. So, go for it, tell me what to write.
Minus 2, minus 4.
We'll be careful.
Oh, plus 4. No.
Well, I'm actually going to write minus negative 4. Okay, you all happy with that? Because remember, we got it's y2 subtract y1 or
But
y1.
wouldn't it be plus?
Well, it's going to turn into a plus, but I'm writing take away negative just to make sure that you don't forget
Yep.
that part.
Over minus 1 minus.
Okay, just the answer. So we've just established that this means that we're going to add it. So we've got negative 2 plus 4.
So that's 2.
Yeah. And negative 1 take away 5. Negative 6. Good.
I thought it was y squared. That's y squared, take away y.
y2 take away y1. You could have done, remember the order doesn't matter.
It doesn't matter at all.
No. As long as you're consistent. So as long as, so the fact that Erin chose this coordinate first, she had negative 2 and subtracted the negative 4. Which meant that she had to start with this coordinate. It was had to do the negative 1 first to take away 5. If she suddenly said 5 take away negative 1, it would have probably wrong. Okay? So as long as you're consistent with when you start. Correct. You can't, we shouldn't leave negatives on the bottom, but there's also something else about this 2/6. Why do I not do it like that? Okay, so you can simplify it. So I'm going to change this whole fraction here to be
negative 1 over 3.
oh, superb. Right, so that is now going to be my starting point. So we've got y is equal to negative 1/3 x plus c. Did it matter which coordinate we used? No. I personally would probably go in this one. Just because it's one that's negative. I just don't like one with negatives. It really doesn't matter which one you stick in though. So, we've got negative 4 as my y is equal to negative 1/3 plus 5 plus c. Oh, wait. No, it doesn't matter which one you choose. Should get the same answer. So we've got negative 4. Oh my gosh, I'm going to stab myself in a minute. Negative 1/3 multiplied by 5.
Negative 5 over 3.
Negative 5 over 3. And we get C on its own. Is equally, not take. Add 5/3 to both sides. What's negative 4 plus 5/3? Don't rush. Negative 7 over 3. Negative 7 over 3. Should have put the same answer. Oh, okay.
No, because I thought you might have to say
No, I don't think so, yes. Very, very nicely. Okay? And where does that go then? Back up to here. Wait. Is a question coming or you're just establishing what's going on?
Why did you, if it became positive, because I chose M, right?
Okay.
And then I did negative.
Let me come and look at yours in a second.
Okay.
Because I think this is my last example to do. Right, so this bad boy is going up to here. Oops. So we've got y is equal to negative 1/3 x minus 7 over 3. Yes? Oh, I lied. It's not the last one.
Yeah, it is.
Yeah, it is.
No. I've got more. No! Only 20 minutes. Right, so, next one. Find the equation of the line. So, we're told the gradient, and we're told where it cuts the y-axis. Oh my gosh, this one is a nice one, isn't it? Because we know that this means
Wait, this.
the y-intercept.
But it's so easy, mate.
And this, they told us it's the gradient. So what's my equation? This one.
Easy. Y equals negative 1/2x plus 4.
Givens. Yes.
So when it says cuts the y-axis, does it mean it's like...
Exactly, yeah, cut.
Okay.
Like, so all of these examples that we're going to be doing is to make sure that you're aware of what, and so in a question they may word it slightly different, and that's what we're going to do with acronyms. So we try and do different examples in class so that you're not thinking, oh god, what does that mean? Okay. So you do need to kind of pay attention to the way they ask it. Right, the next one. You might think, oh, jeepers creepers, but it's also nice and should be straightforward. But this time they've actually said that it's parallel to a line with a slope degree. What do we know about parallel
They're the
lines?
same.
What's the same?
So 2 lines. Gradient.
What about the gradient?
Gradient.
The same. So for parallel lines, they have the same gradients. And slope means gradient. So I know that for my equation, or our one that we're trying to do, it must also have a gradient of 3. So we've got y is equal to 3x plus c. We've been given a point it goes through. So Lily, what do you do now? Yeah, so what would I write? Not y anymore.
3?
Yeah.
Okay, so 3 would be, the x would be minus,
Yep. And what's the y?
and then that's minus.
Yep. Okay, that's what I was trying to.
Oh, yeah, I didn't know. Yeah.
Okay.
That's what I meant.
So minus 2 is equal to 3 lots of minus 1. Yeah. Okay. Haley. 3 times today.
I'm trying.
So we now have to add these numbers. What's 3 lots of negative 1? Negative 3. So we've got negative 2 equals negative 3 plus c. How do I get c on its own? Add 3 to both sides. What's negative 2 plus 3? 1. So c is 1. My equation is
Y equals
3x plus 1. Oh, you are
Yay.
straight line.
Wait, so what would be the difference between, like, what would parallel have to do with it?
So, because it's parallel, that told us what the gradient was. So,
So-
for any question, you need to ask yourself, can I work out the gradient? And then, do I have information to find the y-intercept?
So,
So,
if it wasn't parallel, it wouldn't be the gradient?
no.
So, like, for the next one, we
So,
would...
for the next one, we also have to think, so we have to think a bit harder here. So, this time, it's told us it's perpendicular to it. So, now we have to remember what perpendicular lines, what relationship they have. Julia, was it a question or do you remember?
It was a question. It's about the next question that we're not really talking about right now, so it's fine.
So maybe ask it when we're doing it. So, perpendicular lines. So what about their gradients?
Negative reciprocal.
Oh, yes, people have just said it. They are negative reciprocals. So, if one gradient, if the gradient of this one is negative 3, what's the gradient we want?
Three.
No.
Oh, I don't know.
Negative
Positive 1/3.
Positive. Positive 1/3.
Wait,
Yeah.
how's the third?
So remember, this is secretly negative 3/1, isn't it? Yes? So reciprocal means you flip it. And the negative reciprocal means we change the sign of it
So
to whatever
positive
the opposite is. So our gradient that we need is going to be positive 1/3. Okay? So it's not just the opposite sign, it's the negative reciprocal. You've got to make sure you've got that part in. Okay? So we want the gradient to be 1/3, which means my equation is going to start at y equals 1/3 x plus c. And now we're substituting in those coordinates. So, Julia, can you do that substitution, please?
It'd be -1
Yeah.
equals 1/3 into 4 plus c, and then 1/3 plus times 4 would be 4/3. So it'd be -1 equals 4/3 plus c, and then you take away 4/3 and take away 4/3, and then -1 take away 4/3 is -7/3. -7/3. So then -7/3 equals c. And then you would do y equals 1/3 x plus,
Careful.
minus 7/3.
Beautiful. Beautiful, people. Beautiful.
Oh my.
So you just change the sign of it. Yes. So because this gradient was negative, our gradient would be positive. Yeah. If this had been positive, our gradient would be negative. Yeah. Let me leave it like that for now.
I'm such a smarty pants.
Ow!
Say again. Because it's a negative.
Try to get to the no reaction, okay?
So it was negative 3/1. So that's negative 3/1. So the reciprocal part means it's 1/3. And then we change the sign to a positive.
No, I'm not gonna do it.
Yes? Okay. Alright, we're good with all these.
That's me now.
Yes? Oh, out.